Well, when Claudius Opus 4.5 took an airline booking test, it failed. The task was simple: book a flight for a customer following the airline's policy. The agent read the policy, found a loophole that gave the customer a better deal, and used it. Technically correct. Actually clever. But the test expected a specific answer, so fail. And that's the problem with evaluating AI agents. The thing that makes them useful, creativity, flexibility, the ability to find solutions you didn't anticipate, is exactly what makes them hard to test. Anthropic just published a guide on how to actually evaluate AI agents. It's based on their internal work and what they've learned from teams building agents at scale. And it turns out most teams are flying blind. Here's how it usually goes. You build an agent, you test it manually, click around, try some prompts, looks good. You ship it. Users start complaining. You fix the bug, something else breaks, you fix that, the first thing breaks again, you're stuck in a loop, guessing. The teams that escape this loop are the ones that build evals early. An eval is just a test. Give the AI an input, check the output, measure success. Simple in theory, brutal in practice, especially for agents. See, a basic chatbot is easy to test. One prompt, one response, done. But agents operate over many turns. They call tools, modify state, adapt based on what happens. A coding agent might read files, write code, run tests, debug errors, all in one task. A support agent might verify identity, look up policies, process refunds, send confirmations. Each step affects the next. Mistakes compound. So how do you actually test these things? The first thing you need is vocabulary, a shared language for what you're measuring. A task is a single task with defined inputs and success criteria. Fix this authentication bug. Handle this refund request. Each attempt at a task is a trial. You run multiple trials because model outputs vary between runs. A grader scores some aspect of performance. Did the code pass the tests? Was the tone appropriate? Did the agent use the right tools? The transcript is the complete record of what happened, every API call, every tool use, every response. And the outcome is the final state. The agent might say, your flight is booked, but the outcome is whether a reservation actually exists in the database. This distinction matters. You can't just check what the agent said, you have to check what it did. So what kinds of graders do you use? There are 3 types, and the best evals combine all 3. First, code-based graders. These are deterministic, exact matches, regex patterns, pass or fail tests. For a coding agent, does the code run? Do the unit tests pass? For a support agent, is there a refund record in the database? These graders are fast, cheap, and objective, but they're also brittle. They can't handle valid variations that don't match the expected pattern exactly. Second, model-based graders. You use another LLM to evaluate the output. Was the response helpful? Did it follow the rubric? Was the tone empathetic? These are flexible. They can handle open-ended tasks and free-form outputs, but they're non-deterministic and need careful calibration against human judgment. Third, human graders, the gold standard. Expert review, crowdsourced judgment, A/B testing, expensive and slow, but essential for calibrating your model-based graders. The pattern that works is to use deterministic graders where you can, model-based ones where you must, and human graders to keep everything honest. Now, here's something subtle that most people miss. Agent behavior varies between runs. The same agent, same task, might succeed 90% of the time, or 50%. A task that passed yesterday might fail today. So what does success rate even mean? 2 metrics help here. Pass at K measures the probability of getting at least one success in K attempts. More shots on goal, higher odds of scoring. If you have a 50% pass at 1, you'll succeed half the time on the first try. But if you get 10 attempts, pass at 10 is much higher. You'll probably get at least 1. Pass up to K measures the opposite, the probability that all K trials succeed. This is the consistency metric. If your agent has a 75% per trial success rate and you run 3 trials, the probability of passing all 3 is 0.75 cubed, about 42%. As K increases, these metrics diverge dramatically. Pass at K approaches 100%, pass up to K approaches 0. Which one matters depends on your use case. For a coding agent where one working solution is enough, pass at K is fine. For a customer-facing support agent where users expect reliability every single time, pass up to K is what counts. And at 75% per trial success rate, you're nowhere close to reliable. Let's get concrete. How do you actually evaluate different types of agents? Coding agents are the most straightforward. Software is generally easy to verify. Does the code run? Do the tests pass? Benchmarks like SWE-bench give agents real GitHub issues and grade them by running the test suite. A year ago, models scored around 40%. Now they're above 80%. But even here, you want more than just tests pass. You might add static analysis for code quality, an LLM grader for style, checks for security vulnerabilities. The tests verify the outcome works, the other graders verify how it works. Conversational agents are trickier. Success is multidimensional. Did the ticket get resolved? Did it take fewer than 10 turns? Was the tone appropriate? You often need a second LLM to simulate the user, creating realistic multi-turn interactions. And you need rubrics that capture both task completion and interaction quality. Research agents are the hardest. What counts as comprehensive or well-sourced depends entirely on context. A market scan, a scientific review, and a due diligence report all have different standards. You need groundedness checks. Are claims supported by sources? Coverage checks. Did the agent find the key facts? Source quality checks. Are the sources authoritative or just the first results? And even then, you're grading something inherently subjective. So you understand the theory. How do you actually go from 0 to a working eval suite? Step 1, start early. Start small. 20 to 50 tasks drawn from real failures is enough to begin. Each change to an early agent has a large visible effect, so small sample sizes work fine. Wait too long and you're reverse engineering success criteria from a live system. Much harder. Step 2, make tasks unambiguous. A good task is one where two domain experts would independently reach the same pass-fail verdict. If there's room for interpretation, that ambiguity becomes noise in your metrics. Everything the grader checks should be clear from the task description. Agents shouldn't fail because the spec was vague. Here's a real example. Terminal Bench had a task asking the agent to write a script, but didn't specify a file path. The tests assumed a particular file path. Agent writes a working script in the wrong location, fail. Not the agent's fault, bad task design. Step 3, test both directions. If you only test whether the agent searches when it should, you might end up with an agent that searches for everything. Test where a behavior should occur and where it shouldn't. Anthropic learned this building web search evals for Claude.ai. They needed tasks where the model should search, like what's the weather, and tasks where it should answer from knowledge, like who founded Apple. Getting that balance right took many iterations. Step 4, read the transcripts. This is maybe the most important advice. You won't know if your graders are working unless you actually look at what happened. When a task fails, the transcript tells you whether the agent made a genuine mistake or whether your graders rejected a valid solution. Anthropic invested heavily in tooling for viewing transcripts. They read them regularly. And step 5, watch for saturation. An eval at 100% pass rate tells you nothing about improvement. It only catches regressions. As capability evals approach saturation, you need harder tasks or the metric becomes meaningless. One more thing. Automated evals are powerful, but they're not the whole picture. Think of it like the Swiss cheese model from safety engineering. Each layer has holes. No single evaluation method catches everything. But stack enough layers and failures that slip through one get caught by another. Automated evals run on every commit before deployment. Production monitoring catches issues in the real world that synthetic tests missed. A/B testing validates changes with actual user outcomes. Manual transcript review built intuition for failure modes. Human studies calibrate your model-based graders. The teams that build reliable agents use all of these. Evals are the foundation, but they're not the whole building. There's something almost philosophical about this whole enterprise. We're using AI to evaluate AI, building systems to test systems. The grader that judges whether your agent's response was helpful is itself a language model that might hallucinate or miss nuance. It's turtles all the way down. But that doesn't mean the effort is pointless. It means you need multiple layers, multiple methods, constant calibration against human judgment. The alternative is worse, shipping agents and hoping for the best, fixing bugs only when users complain, never knowing if your changes made things better or just different. Evals don't give you certainty, but they give you signal. And in a world where AI agents are increasingly handling real tasks with real consequences, signal is everything. If you're building agents and want to dive deeper, Anthropic's full guide is linked below. It's one of the more practical things I've seen published on this topic. And if you're not building agents, if you're just using them, now you know why they sometimes fail in weird ways. It's not that the teams behind them don't care. It's that testing creative, flexible, autonomous systems is genuinely hard. Every team is still figuring it out.